For those of you that are interested in hyperspectral information or trying to separate out minerals based upon their electromagnetic fingerprints, you might be interested in looking up some hyperspectral information. So hyperspectral differs from multispectral in that you kind of get this cube of information. There's so much dense information in the spectral dimension that we kind of think of this as an entire cube. So an image is obviously your X and Y locations, but we also have a very dense spectral information. And you can see with a number of different sensors, unique information about different types of things that aren't necessarily visible to the naked eye. So food processing actually uses hyperspectral cameras because they're able to detect a lot more information about particular elements. Mineralogy uses it to separate out different sorts of minerals. You can even see here different types of gases can actually be detected by this hyperspectral camera. So the increasing the spectral resolution helps us detect certain things or separate out different elements, in this case here, different sorts of minerals. Now, you can learn a little bit more upon or see the benefit of hyperspectral by looking at the USGS Spectral Library. Here is a library of many different sorts of information, documentation of rocks, minerals, soil, etc. All the work that's been done to collect information upon the spectral properties of the surface is available in this library. So for instance, if you wanted to click on the library, you could do an interactive version of it, and you can look up the profile of different minerals. So in this case, I've looked up gypsum here, and I can look up the plot or the spectral signature of gypsum. And perhaps I wanted to compare this to other sort of minerals. I could look up them here and understand what the spectral differences there are between different sorts of minerals. There is even vegetation, here you can look up as well. So there's a lot of different things like looking up the difference between like aspen trees and blackbush trees, for example. So the USGS Spectral Library is a great place for understanding what sort of spectra differences there could be. If you want to look about getting hyperspectral information, I'd recommend a number of different sources. There's a website called HyperLabelMe, which is basically a benchmarking system where they've collected a number of different databases and they've looked into distributing them for purposes of benchmarking, let's say, atmospheric correction or image classification purposes. I do believe these data sets are available, but you have to sign on in. But a really good source of hyperspectral data is actually the AVIRIS platform. So AVIRIS stands for Airborne Visible Infrared Spectrometer. And there's actually AVIRIS and AVIRIS NG standing for New Generation. In both cases, you could simply look up AVIRIS or AVIRIS Next Generation. And they both have handy-dandy data portals. Note that this shows you that this is an actual like airplane system. So this is like your raw data where the plane's shifting and tilting because of the movement of the aircraft with wind, and there's your actual ortho-rectified or corrected data. Either way, you can go to the data portal page, and here is an individual map that shows you what data sets have been captured, and all of this stuff is downloadable. So you can take a look at what's been done here for AVIRIS Next Generation. It looks mostly like it's mostly going to be in the States, and this is some of the work that I've been doing up here with the NASA Above project, we were doing some work in this region here for Nuvik, trying to see the impacts of climate change in the Arctic. So the next generation satellite tends to have a lot of work on that dark snow project that I was talking about. If you were just to Google Avaris, the original one, and go to its data portal, you can see here, I don't know why they've separated out into two different portals, but they have. You can get a lot of information here. This has been going on for a bit further on, but the Deepwater Horizon had the Avaris satellite flying significantly around this region here to look at oil spills. So if you are interested in that, there's a good amount of information on using these hyperspectral technologies to detect oil spills, as well as there's even a bit of information upon here. Didn't quite get into Canada here, although there is one in Mare Blue, which is a peatland that I work in, and a few other sites in the north here in Vancouver. So this is another source of hyperspectral information. Sometimes you could simply go and look at applications that sell cameras. They'll sometimes give you hyperspectral information. So you might be able to, like in this case here, this is IMSpec Hyperspectral. They have a couple of images that are free. There's actually one satellite hyperspectral system called EO1 Hyperion. It is a hyperspectral thing that has a good 30-meter resolution, so you could compare Landsat to Hyperion. I believe it's available through Earth Explorer. And sometimes you also, again, see sort of Multispec has some free data sets as well for anybody who's interested in hyperspectral.